Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 13, Bonding and Orbital Approach Part 2. This is our second and our last video in Chapter 9. Here are our objectives for today's video. Pause here. You don't need to draw the picture. So do you remember in the last video, and if you don't, just go back and refresh your memory, that when we have sp2 or sp hybridizations, that we have one or two unhybridized, typically considered to be empty orbitals. And you were probably wondering what the point of that was if they were empty, and that's a totally legitimate thing to wonder. And the point of that is electron delocalization. So when you have multiple sp2 or sp atoms that are adjacent to one another or next to one another, electrons that are in pi bonds can delocalize, or electrons could rather go into those unhybridized orbitals. They can delocalize it, which stabilizes the molecule. So the picture that I have is it's showing that there are all of these unhybridized p orbitals that are adjacent to one another. That's what we're seeing in B. And then in C, because they are very close to one another, they're able to overlap with one another, constructive interference, and they're able to delocalize over all 6 of those orbitals, and that stabilizes it. Pause here. I'm just going to say the answer out loud since this one should be pretty straightforward. If you're not already familiar with this notation, I will explain that. So at every corner, there is a carbon, and it is surrounded by sufficient hydrogen atoms to be electronically neutral. The molecule on the left is more stable than the one on the right. The reason why is because you have you have more sp2 hybridized atoms that are adjacent to one another. That's able to delocalize those double bonds, which makes it more stable. Pause here. You don't need to draw the pictures. So I probably discussed this with you last year, but we're going to just talk about it a little bit more again, which is constructive and destructive interference. So if you have 2 waves that are colliding in a way that increases the overall amplitude, this is called constructive interference. Whereas if they're interacting in a way that reduces or completely cancels out to 0 the amplitude, that's called destructive interference. So if we're talking about orbitals, these are the wave-like properties of electrons. They can constructively and destructively interfere with one another, which is why certain molecules do not exist, because there's too much destructive interference. Pause here. So when you have orbitals that are interfering constructively, they're going to form molecular orbitals. Those are the electrons that go into covalent bonds. But when atomic orbitals interfere destructively, they form what are called anti-bonding molecular orbitals, which really means that they make it such that an atom cannot bond. I'm going to show you some diagrams of this in class with something called molecular orbital theory. It's not on the AP exam, but it's something that just puts this in a way that's very visually appealing. But I will show that in class. You don't need to have it in your notes. Pause here. And then our third sort of category of bonding, antibonding, would be non-interference, so meaning that there's no overlap of orbitals whatsoever. And that's what happens with ionic bonding. And that's why I have said probably many times that ionic bonding is really not technically bonding. It's actually an extremely strong intermolecular force, which is what our next chapter is on. Great. Here are the additional practice problems for today's video. Thank you so much for watching and have a great night.